And here is your lesson on transform plate boundaries. All right, so the teaching point will be able to describe how tectonic plates move at transform boundaries and identify the effects and landforms associated with this movement. All right, launch for this lesson. Two cars are moving side by side. That's the key thing here at different speeds on a narrow road might scrape or collide. How might this idea help explain what happens along certain plate boundaries? All right, so maybe one car, right, can be going faster than another car, maybe slightly faster. And if it's narrow enough and might not have a lot of room to move around except for a small portion of the thoroughfare, so the sides of these cars can eventually scrape. All right, and they might, once they do scrape and collide, they might be moving at the same pace, but eventually maybe energy can be built up in which maybe a car can begin to accelerate and go faster than the other car. That's what's happening here at your transform plate boundaries. Transform plate boundaries go side by side. There is no vertical movement at all. There is vertical movement for converging, right? One plate moves underneath another plate. And at divergent plate boundaries, we have our Rift Valley. And the Rift Valley, you'll have several blocks of land masses that have been fractured. So there is vertical movement at the Rift Valleys. All right, transform plate boundary, a place where two tectonic plates slide past each other horizontally, not vertically, often causing earthquakes. All right, we can get some severe earthquakes happening here at transform plate boundaries. I'll explain to you one of them on the next slide. This picture here on page number 11 of your reference table, this is probably the only place where you would have the transform plate boundary by your offset ridges. So here is a ridge, mid-ocean ridge. Here's another mid-ocean ridge, and in between these ridges would be a great example of a transform plate boundary. All right, great example of this plate boundary is at the San Andreas Fault. On the old reference table, it was actually clearly marked as a San Andreas Fault, all right, but now it's not. But that's the area here. We have these two arrows that kind of go side by side. One's going in one direction, other one's going in the opposite direction, right? And it's sliding past each other. There may be some vertical movement, but we're talking about horizontal. All right, great example of this with earthquakes is there was a World Series back in I think it was 1988 or 1989, and that was the Battle of the Bay. You had Oakland versus San Francisco. Oakland A's versus the San Francisco Giants, and that it was somewhere up here. It was game 5 or game 6. They had an earthquake magnitude, I think 6.9 on the Richter scale. Shook the earth. Definitely gave a big scare. They continued the World Series. 1989, I was young. I forgot who won the World Series. Maybe Oakland. I think it was Oakland who won at that time. Yeah, I don't think it was San Francisco. All right, but you have two major cities that run through the San Andreas Fault, or the San Andreas Fault runs through these two major cities. One is called Los Angeles, right, which is around here, LA, maybe I'm sorry, up here. And the other one is San Francisco. All right, at this plate boundary, crust at this plate boundary is neither created nor destroyed. All right, it's a little redundant there, sorry. So created at diverging plate boundaries, mantle rises toward the surface and creates new crust. So you're not creating crust there. And we have the crust that can get destroyed if it has subducted into the mantle, that plate can get destroyed. All right, so this one here is strictly on the surface. All right, movement is often irregular to build up friction. All right, so friction will get built up, just like that car by car scenario. And if you begin to wear away a portion of the rock that's really holding up these land masses together, and once you wear that away and grind that out, then it's going to slip and cause a major earthquake, like in 1989 for that World Series between the A's and the Giants. All right, so we have some topographic features. We have strike slip faults, a type of fault where rocks on either side move horizontally past each other. So strike slip faults and transform faults are synonymous, right? You can use it interchangeably. All right, they produce some linear valleys, right? Linear, we think of lines or straight lines, and valleys are low portions of land masses. All right, so linear valleys are long, narrow depressions on the Earth or in the Earth's surface that form along fault lines, at least along the transform fault line. And number 3, offset streams and roads. So I found this online. All right, so here's a road that was once straight. All right, we have some strike slip or transform fault boundary here. So the fault boundary is kind of running at an angle going across here. All right, so this portion of the street is moving, let's say, if this is north, maybe toward the northwest, and this is moving toward the southeast in that direction, sliding past each other. But streams can do this. If this was a stream, the streams, right, can get offset, right, and maybe create a new channel and new forms of erosion, perhaps. Maybe this is along mountain ranges. Maybe mountains can get offset. All right, hazards. The major hazard of transform plate boundaries are earthquakes. There is no association with volcanism at all because there is no rising or sinking of land masses, right? Or perhaps the addition of magma from the mantle rising upwards, right? There's none of that happening at transform fault boundaries, strictly earthquakes. All right, and that's it for this lesson. All right, I'll put up the Nearpod link, and you guys I have some practice questions on there with the time and climb. All right, enjoy, and thank you.